What is going on YouTube? This is the Middle School Math Man. This video is going to be on quadratic equations, but more specifically we're going to be talking about solving them, finding the solutions using the square roots method. Before we get started, I just want to talk about this basic concept here. Why do positive real numbers have two square roots? Now you're going to see that a lot of these problems, a lot of the quadratics are going to have two solutions. So kind of the math behind why that is if you think about, let's say, 25. Now we know that 25, if we take the square root of 25, we know the obvious one is going to be 5 times 5. Right? The square root of 25 is 5. We've known that for a very long time. However, negative 5 times negative 5 is also 25. So that's why technically there are two answers there. It has two square roots. You take any positive real number, so for example, square root of 144. Well, 12 times 12 we know, but also negative 12 times negative 12 equals 144. So you might see this symbol. This symbol is basically just says plus or minus, right? So if we say plus or minus 5, that means that it is 5, but also negative 5. And it comes from the math that we just did right there. So let's take a look at our first problem. We're going to solve it using the square roots method. So the main thing we want to do here, just like we're solving any normal equation, we want to isolate the variable. We want to isolate the x squared term. So if we're looking at this problem, it's not a whole lot of steps to this, but if we're trying to get x squared by itself, well, we need to divide both sides by negative 5. So we're left with x squared equals positive 100. So now at this step, if we are trying to get the x by itself, we need to take the square root of both sides. When we take the square root, that gets rid of the squared, and then we're just left with x. So the square of 100 is 10. But remember, we just talked about how this positive real number has two answers. So a short way of writing 10 and negative 10 is plus or minus 10. And actually, more specifically, we're going to represent our answers using curly brackets. The negative numbers should come first, so we have negative 10 and 10 as our answers. Moving on to the next problem. This one requires a little bit more work. There's another step in here. So just like we were solving this, if there wasn't the square there, if it was just 9n plus 10 equals 91, that would be a two-step equation, right? We got to get the variable by itself. So we have 9n squared equals 81. And then I'm trying to get the n squared by itself, so I would divide both sides by 9. And then I'm left with n squared equals 9. Now the last step, to get the n by itself, we're going to take the square root of both sides. So I get n equals plus or minus 3. So my two answers are negative 3 and 3. And I'm going to put those inside the curly brackets. Ignore my really bad curly brackets. So both of these problems have two solutions. Alright, I'm going to move on to the next one. These ones might be a little bit different. So I'm going to isolate the n squared. Negative 144 divided by 2 is negative 77. Now, if you notice, we have a negative number there. So when we are taking the square roots, we cannot take the square root of a negative number. So this answer is going to be no solution. We can't take the square root of a negative number. If you were to do that on a calculator, it would give you an error message. So anytime that happens, we are going to have no solution. So we have two types of solutions so far. We have the quadratics that'll give us our two solutions. Those are kind of the normal problems. But we could come across a problem that has no solution. Here's an example of what that looks like. Then moving on to the last type of problem. So if I'm trying to get that x squared by itself, negative 21 plus 21 is 0. So this one's a little bit different. Right? If we take the square root of 0, the square root of 0 is just 0. Right? 0 is not positive or negative. So in this case, there would just be one solution, and that solution would be 0. So whenever we're solving using the square roots method, there are three types of solutions. We can have two answers, like the first two problems we did. We could have no solution, or we could have one solution. In this case, it was 0. We are going to do one more problem here. This problem is going to be a little bit more difficult than the other ones we've done. It's going to require a couple more steps. So in this problem, like we've mentioned earlier, you need to get the term that is squared by itself. Now in this case, the x minus 6, that is what's in parentheses, that is what is being squared. So we're trying to get that x minus 6 by itself. So in order to do that, the first step we need to do is we need to get rid of that 4. So 4 is being multiplied by that stuff, so I'm going to divide it. And then I'm left with x minus 6 squared equals 4. So this problem is like the previous ones we've done. It just looks a little bit different because it's not just x squared, we have x minus 6 squared. So in order to get rid of that squared, we want to get x minus 6 by itself. We're going to take the square root of both sides. Now when we take the square root of x minus 6 squared, we're left with x minus 6. That squared is not there anymore because we took the square root of it, we did the inverse operation. And then the square root of 4, remember the square root of 4 is positive 2 and negative 2. So now we are not done yet because as you can see at this step right here, x is not by itself. We don't know what our solutions are yet. So we are actually going to have to set up two more little simple problems. So x minus 6 equals, remember it's not just 2, we have 2 and negative 2. So that's where our two little problems are going to come from. So now I'm just going to solve these. These are just little one-step equations. So I get x equals 8 and x equals 4. Alright, so sometimes the problems will require a little bit more work. Sometimes the variable won't just be by itself.